Hello everyone, this is the other movie that I make in order to deliver you the last point of chapter 3. So this is the last point of chapter 3. That means this movie is the last movie for chapter 3. Okay, the last point of chapter 3, measures of dispersion by using group data. To measure the dispersion of group data, we need to find a range, mean deviation, variance, and standard deviation. Okay, what does it mean group data? Group data refer to data that already classified, grouped, or categorized into frequency distribution. So in short, it means the data that already passed 5 steps. Step 1, find class frequency. Step 2, class interval. Step 3, class limit of each class. Step 4, tally. Step 5, frequency. Okay, suppose that we have frequency distribution table and we need to find range. How to find range? In order to find range, you need to find HK. What is K? K is number of classes that is consistent with first step of our 5-step method. So H is upper limit value, K is number of classes. So in this case, it should be upper limit of the last class. So K, it should be the last class. Okay, K class. Minus L, L is lower limit or lower value of the class 1. Lowest class is class 1. That's why in order to find range for group data, you need to find by looking the group data table. You can see HK and you can see L1. Just take HK minus L1, you can get range. Okay, next, mean deviation. Mean deviation, in order to find mean deviation, you need to find first midpoint class. Okay, midpoint class. So midpoint class from class 1 again. Midpoint class, midpoint I should become from 1 to K. I equal to 1, midpoint class 1, I equal to 2, midpoint class 2, I equal to 3, midpoint class 3, I equal to K, midpoint last class. When you got midpoint, next you need to find arithmetic mean or group data. Okay, this is next. After that, you need to find deviation from midpoint class to arithmetic mean. After that, you need to put value sign in order to delete or in order to eliminate the sign. No positive. In this case, there's no negative positive, there's no negative, no sign. We put absolute value in order to delete the sign or in order to eliminate the sign. After that, because we're talking about group data set, so we take this one, what we have just found, multiplied by class frequency. Okay, multiplied by frequency. Next, add all of them together. And then divide it by n. Okay, I think you can follow me by this step. Then divide it by n. So this is mean deviation or absolute mean deviation. Okay. So first you need to find midpoint class, arithmetic mean, deviation, put deviation into an absolute value, and then take the absolute value of deviation multiplied by class. For example, this is class 1, frequency 1, class 2, frequency 2, class 3, frequency 3. And then add them together, divided by n is mean deviation. How to find variance? Similar to mean deviation, in order to find variance, first you need to find midpoint class, the midpoint class from class 1 to class k. Okay? If I equal to 1, this is midpoint class 1. If I equal to k, this is midpoint last class. Then you need to find mean deviation after, not find mean deviation. You need to find mean arithmetic mean, and then you need to find mean deviation. Next, we don't put absolute. This is different from mean deviation. Because mean deviation we put absolute value, but this is not put absolute value, but we take this deviation into square. Take this deviation to square, and then we multiply this square to frequency. If it is class 1, midpoint class 1, this is frequency class 1. Midpoint class 2, this is frequency class 2. Midpoint class 3, this is frequency class 3. Okay? And next we add them together. Next step, the last one, we divide it by, take this, divided by n minus 1. Maybe some of you will ask me why divided by n minus 1. I already answered in a previous movie. Okay, this is we call variance. This is we call variance. If you know variance, you can find standard deviation. Okay, how to find standard deviation? Just take square root. Just take square root here. This is standard deviation. This is variance. Take square root is standard deviation. Okay, standard deviation is the square root of variance. Okay, this is a formula that we use in order to find sample variance. It the same thing as we find the sample variance in ungrouped data. We have two formulas: conceptual formula and computational formula. This is conceptual formula. I already explained a previous slide in this case. And this is computational formula. Conceptual formula, you need to find mean deviation. Sorry, you need to find arithmetic mean, not mean deviation. But for computational formula, you do need to find mean or arithmetic mean. Okay. So previous movie we already looked at how to find the difference between conceptual formula and computational formula. So this is the same thing. I'm not reading for you. You can read by your own. But again, just note that if you are using conceptual, you need to find arithmetic mean or group data. But if you are using computational, you don't need to find arithmetic mean or group data. Okay, so this is the difference between conceptual formula and computational formula. Yes, when you have a variance, you can find standard deviation, just take square root. Okay, let's go to practice. Suppose that we are given cell frequency distribution of 50 sellers below. So there are 50 sellers that sell products into the market, sell product into the customers or buyers. Uh, every seller, they have different ability to sell. From data that we just given, we can classify this data into frequency distribution like this one. Okay, so this is frequency here represents the seller. This is cell represent quantity or number units of product sold. So based on this table, we can see that there are 12 sellers who can sell the product from 50 to 60 units per day, because daily. There are 13 sellers that sell product from 60 to 70. There are 12 sellers could sell product from 70 to 80, and so on. Okay, based on this frequency or cell frequency distribution, compute variance, standard deviation. Okay, so first I will use conceptual formula in order to find variance, and then after finding variance, we can find standard deviation. So this is a frequency distribution from previous slide. So in order to find variance, you need to find midpoint. X is midpoint. Yes. In order to find midpoint, remember that one. In order to find midpoint, L1 H1 divided by 2. L2 H2 divided by 2. L3 H3 divided by 2. This is L1 H1 divided by 2, L2 H2 divided by 2, L3 H3 divided by 2, L4 H4 divided by 2, L5 H5 divided by 2. Okay, so this is the way that we find midpoint. Next, find the products of midpoint and frequency. The product is the result from multiplication. So by taking 12 multiplied by 55, we got this one, and so on. After that, we add them together, divided by n. This is we call arithmetic mean or frequency distribution. After we find mean and we know midpoint class, we can take deviation, midpoint class to the mean, and then take the square. Next, multiply by frequency of each class. So by frequency of each class, multiplied by square. Okay. Frequency multiplied by mean deviation, square the mean deviation, we got this one. Next, add them together. Then divided by n minus 1. This is variance. Take square root, this is standard deviation. I can say this is because this is represents quantity. Quantity of product cannot be 12 point something here, so I can say that 13. Okay, how to interpret the 13 or 12.6? In order to interpret 13 or 12.6, we need to start from mean. Based on the table, there are 50 sellers. That each seller has ability to sell different amount of product every day. But we suppose that Among 50 sellers, average ability of each seller to sell is 71 units per day. Okay, among 50 sellers, some seller could sell less units, some seller could sell more units, but just say average. Among 50 sellers, in average, each seller could sell 71 units per day. In average, each seller could sell 71 units per day. But in average, some seller could sell more than average. Some seller, they are good for selling. That's why they could sell more than average. How many units more than average? By 13 units. But some seller, they did poor job. They sell less than average. Or maybe the ability to sell just very low. How many units low? 13 units lower than average. Okay, so among 50 sellers, we suppose that by finding this one, we suppose that each seller could sell product every day in average 71, or in average, in general, each seller could sell product 71 units per day. But among 50 sellers, there are some sellers, they are outstanding for selling, they could sell more. So in average, they could sell more, 13 higher than average. But among 50 sellers, some sellers, they have lower ability to sell. So in average, among 50 sellers, some sellers could sell less than average. In less than how many units? Less than by 13. What is 13? 13 is here. Okay, first you need to based on average, and then you need to find one standard deviation and less than one standard deviation. So plus one standard deviation and minus one standard deviation. This is referred to good seller. This is referred to low ability seller. So this is the result from using conceptual formula. How about computational formula? Okay, look at this one. Computational formula, you need to have a small table. You need to make more 3 column. For conceptual, you need to make how many column? 1, 2, 3, 4, 5, 6. You need to make extra 6 column in order to compute conceptual, to compute variance by using conceptual formula. But if you use computational formula in order to calculate variance, we need only 3 column more. First, you need to find mean deviation. You need to find the product between mean deviation and frequency. Next, you need to take the square of midpoint multiplied by frequency. Okay. Okay, doing the same. We have the same results, but using different formula. That's why in your time for practice, or doing quiz, or doing exam or interview, if the exercise asking you to find variance and the data set is group data, you can use conceptual or computational. Don't use both. But here I use both formulas for you in order to show you whether these two formulas provide the same job or not. Yes, they are providing us the same job if we use the same data set. Okay, so go to textbook. You can see page 80. Page 88. Yes, this one. Page 88, you can see this is the example that you need to study, because example provide you the solution. This is solution. And we also have the other example and the others, and also solution. So you have two examples on page 88 and 89, one example. Page 90, the other one example. You have cell review on page 90 and 91, cell review. Okay, so this is your working time. You need to spend your time to practice, to work, in order to get clear understanding how to proceed to find variance standard deviation from group data. Okay, the standard deviation is commonly used to compare the spread in two or more set of data. So in this case, if you have two set of data or three set of data, and you want to find which data set that have more spread, so you need to compute standard deviation from our data. And if if one data set show you or provide you the largest standard deviation, so the data set is more spread than the other. Okay, the other concept is Russian mathematical or statistician, Russian mathematician or statistician. So based on this person or this guy, he developed one model. This is his idea. For any set of observations, for any set observations data set, sample data set or population data set, the minimum proportion of values that lie within k standard deviation is at least one is at least in this area. Okay, I can say what is this area? It should be 1 minus 1 k square. Okay, this is k, right? Don't confuse k is here. K here is number of classes in our frequency. So k here is not frequency. This is not based on Chebyshev theorem. We don't use group data. This is just find the minimum proportion. Okay, so k here is not total number of classes in a group data. So because this is we don't talking or we don't showing, we don't seeing group data. So k here is number of standard deviation. K here is number of standard deviation from the mean. Okay, k must be greater than 1. K is number of standard deviation from the mean for this area. Don't confuse. Okay, so Chebyshev theorem by Russian mathematician is concerned with any set of values, any set of data that is the distribution values of data can be any shape. Any shape, it should be symmetric or non-symmetric. Non-symmetric, based on what we have seen so far, it should be skewness, skew to the right or skew to the left. K is number of standard deviation from the mean. Okay, you can go to your textbook, you can go to page 86. Yes, this is page 86. Okay, learn it this one. So K is 3.5 standard deviation. I can draw that one. This is mean. 1 standard, 2 standard, 3 standard, and a half standard. So from the standard here, from the mean here to this point, 3.5 standard. This is plus 3.5 standard, and we also have minus 3.5 standard from the mean. Okay, that's why you can see plus the right hand side of from the mean to the right hand side, minus the left hand side from the mean. Okay, so normally it's a symmetric. If this is a 3.5 standard plus, must be 3.5 standard minus. Okay. Okay, I also have example the other one. The mean or income or groups data set is 500. A sample. Standard deviation is 40. According to Chebyshev theorem, at least what percentage of income will lie between 400 to 600. Okay, suppose that I draw this is 500, this is 600, this is 400. So from 400 to 600, how many percent? How many percent? Okay, that's why we need to find K. Based on Chebyshev, you need to find K. If you cannot find K, you cannot find how many percentage. Okay, let's see. Answer. Based on the information given, we can see that mean 500, standard deviation 40. Finding K, K is number of standard deviation from the mean. We don't have K here. In example on page 86, you have K, but in this case we don't have K. Even though we don't have K, we need to find K. Okay, how to find K? This one, how to find K? Okay, K equal to 100 divided by 40. So equal to 2.5. Maybe you can ask, why we take 100? How to get that 100? Okay, this is because from the mean 500, from the mean to from the mean of 500 to 600, 100 increasing, plus 100. That's why plus 100 here. From the mean to 400, from the mean 500 to 400, this is minus 100. That's why we got minus here. Divided by number of K. So from 500 to 600 is $100. Is $100. But $100, how many standard deviation? In order to find how many standard deviation, you need to find you need to take this value divided by one value per standard deviation. How much money per standard deviation? 40. That's why divided by 40. So we get 2.5. 2.5 plus and also 2.5 minus. Okay? That's why we find K now. K is 2.5. What next? Based on formula, we get it. So 84. That means from That means from 400 to 600 income, they are 84%. 84%. Okay, they are 84% lie here. That means 84% our income from 400 to 600. Okay, this is, you want to find a percentage. So in example on page 86, you have standard deviation. But in this example, we don't have a standard deviation. If you don't have number standard deviation, you need to find K. How to find K? It depends on the question asking. Okay, this is not from the mean, this is from the lowest to the highest. That's why mean, it should be the middle. Mean should be the middle, because mean, this is lowest, this is highest, sorry, lowest that we want to see and higher that we want to see. That's why mean must be in the middle. So from mean to higher to mean to lower must be equal. That's why equal here. 2.5 plus 2.5 minus. Okay. Empirical rule or nominal rule. This is a symmetric. So based on this rule, we can see that if you have mean, and you want to find one standard plus and one standard minus, is about 68%. Two standard plus two standard plus from the mean and two standard minus from the mean, 95%. Three standard plus from the mean and three standard plus and three standard minus from the mean is 99.7%. Okay, so this is a population symmetrical population data set. If you're talking about symmetric, mean, mode, median is always at the same point. From one standard from the mean plus minus and one standard from the mean plus, that means it should be two standard here. Okay, two standard is 68%. Two standard deviation from the mean and two standard deviation from the mean minus two standard deviation from the mean plus, together 95%. 99%. Sample, this is a population because I use MUI. If I'm talking about sample, this is X bar, the same. Okay, the same. Okay. Okay, come to the last of this chapter. This is also homework. You have two homework today. Two homework, right? I think two or one. Okay, only one. Actually two homework. This one should be homework for you, but I also take it into my explanation. Okay, this is last homework for chapter 3. Go to your textbook. Go to the textbook. Exercise number 58, number 59, number 60, 61, 62 on this page. Okay, on this page. This exercise number here is group data set. Based on group data set from this exercise number, you need to find variance and standard deviation. Variance and standard deviation. Don't follow the question on the textbook. Just take the data set from this exercise number and calculate variance and standard deviation. Okay, this is the last movie or the last minute of for exercise. Oh, sorry, not for exercise. For chapter 3. Okay, go to you for learning and doing practice together doing homework.